In this video, we are going to talk about inverses. We will find the inverse of this equation algebraically. We will find the inverse of this relation, where we just have a list of ordered pairs. And we will use function composition to determine whether or not these two functions are inverses of each other. Okay, if you have an equation and you want to find the inverse, there are two main steps. Step one, let's see, let me write this down. Step one, switch x and y. Step two, solve for y. So those are the two steps I'm going to do. So first we switch x and y. So if I rewrite this, switching x and y, I have x equals 2y minus 4. So now I have switched x and y. Now I'm going to solve for y by adding 4 to both sides. So that gives me x plus 4 is equal to 2y. And now I'm going to divide both sides by 2. Okay, now I have a choice. I can either leave it like this. Okay, so I'm going to have y equals x plus 4 over 2. Or I could have split this up, okay, and while I'm at it, I'm going to reverse this around. I could have put the x over 2 and the 4 over 2. So if I imagine that I did that, x over 2, and then I had the 4 over 2. But would I really leave 4 over 2? Of course not. 4 divided by 2 is 2. So if I did it this way, I would have a 2. Okay, so either one of these would be acceptable. Now, if you want to find the inverse of a function given a list of points, remember these two steps we did on the last problem? Step one was switch x and y. So for a problem like this, you just only have the one step. You just switch x and y. So the inverse would be 9, 6, negative 8, negative 3, negative 5, 11, 7, negative 1. All right, that's all there is to that. Okay, now finally we're going to use function composition to determine whether or not these two functions are inverses of each other. Okay, so we have to do two things. We're going to substitute each function into the other and see whether or not they equal x. So on the one hand, I'm going to take function f, and then I'm going to substitute function g inside of it. Okay, and on the other side, I'm going to take function g and put function f inside of it. All right, and in each case, if they're inverses, everything should cancel out and I should just get x. So let's start with this. I'm going to take function f and substitute function g inside of it. So function f is 10x plus 5. So I'm going to write parentheses instead of x. So 10x plus 5 becomes 10 parentheses plus 5. Okay, this is function f. 10x plus 5 becomes 10 parentheses plus 5. I'm putting parentheses because I'm going to substitute in function g, which is negative 2x plus 2. So I have negative 2x plus 2. Now, if I do this distributive property, that's going to be negative 20x plus 20. But then I have this 5, so I'll bring that down. Okay, if I simplify this, then that's going to be 25. So I have negative 20x plus 25. Everything did not cancel out. I did not get x. So right there, I know that these are not inverses of each other. Okay, just for fun, let's look at the other side, although we already know they're not inverses. But if we looked at it the other way, then we'd start with function g, which is negative 2x plus 2. So that would be negative 2 parentheses plus 2. And then inside goes function f. So I would put 2x plus 5 in there. Okay, let me get this space back. If I do the distributive property here, that's going to be negative 20x plus, minus 10. And then I have this plus 2. So that's negative 20x minus 8, combining those like terms. So again, you did not get x, so they are not inverses.